we're looking at a little something here. I have given you a function, and I'm asking for one specific feature of the graph of this function called the end behavior. You'll be studying these types of things, seeing where they have maximums and minimums and the like in calculus. But something that's really an algebra issue is what kind of behavior do I expect as I move way out to the right? Very large positive values of x. Or way out to the left, very large negative values of x. And these are things that we can address rather efficiently if we realize what term in here really dictates. What I'm going to look at is this guy. I intentionally put these things out of your typical order because this is the term that's going to dictate that behavior. Because note, this term, since there are 3 factors of x, is going to be x times this term. And since I'm talking now exclusively about very large values of x, this term is much larger than this term, and this term in turn is much larger than this term. So really the end behavior of this graph is entirely dictated by this guy right here. And now I'm going to ask myself, what happens to y, for example, when x gets to be a very large positive number? X is large positive. That means I have moved way out to the right. What happens to the y? Y is a plus. X cubed will be a large positive number. And plus a large positive number. Y will also be large positive. So the end behavior, I'm going to simply signify it by showing that I expect if I stood far enough back from my graph, I'd see the graph taken off like this. How about the other end? If x is large negative. And note, I'm not saying anything about what goes on in here. I'm only thinking one particular aspect of the graph of this function. Well, when I cube a negative number, I get a negative number. So y will also be a large negative number. What do those mean? Large negative x's means I'm traveling out this way. Large negative y's means I'm traveling down this way. So symbolically, I'm going to represent it as this. Again, if I stood far enough back from my graph, that's the kind of thing I'd see. I'd probably see some wiggling going on in here, but far enough back, it's going to look like that. That's what we're talking about when we mean end behavior. And note, it really consists no more about than identifying which term is going to control things, and then asking yourself, what happens when x gets positive? What happens when x gets to be large negative? So this is how I'd represent the end behavior. On the handout that I gave you, I gave this in multiple choice form. So you'll find this as answer C on the multiple choice.